Hi everyone, so I know I have been stuck on question 4 of the CSEC Add Math 2023 Paper 2 solutions. I want to finish this up in the best way that I could so that I can go on to the May 2024 Add Math Paper 2 solutions. So in the last video that I did, I looked at question 4 part A, which is on the section Introductory Calculus, and that was on differentiation. So let's look at part B, which is on kinematics. So we have a drone that is tracking the movement of an object in motion on the ground. The following movements are recorded. It moves at a constant velocity of 4 meters per second for 5 seconds. Its velocity increases uniformly for 3 seconds to 10 meters per second. It moves at that velocity for 7 seconds, and it slows uniformly until it comes to rest after 4 seconds. So we have to sketch the graph of the movement of the object, and notice we're given us a grid with velocity in meters per second on the y-axis and time in seconds on the x-axis. And the sketch is worth 3 marks. So I'm going to zoom out so you'll see the entire graph. So I know it's a little bit small at this point, but we have to put in the units, alright, or the graduations on each axis. So let's say on the x-axis, each centimeter will be 2 seconds. So I'm just going to graduate it up to 20. Okay, and on the y-axis, let's let 1 centimeter to be 1 meter per second. Right, and we're just going to go up to 10. Okay, so I'm going to zoom back out. All right. So the first movement, the object moves at a constant velocity of 4 meters per second for 5 seconds. So the object is already moving. So for up to 5 seconds, all right, which would be midway between 4 and 6. So here, the object is already traveling with 4 meters per second. So it's moving at a constant velocity, so that means it's a straight horizontal line like that up to 5 seconds. Then the second part, its velocity increases uniformly for 3 seconds to 10 meters per second. So 5 and 3 up to 8 seconds. Right, so it increases its speed to 10 meters per second. All right, so up to 8 seconds will be, all right, up to this line here. All right, so this is the next point. All right, so that's the next part of the journey. All right, then it moves at that velocity for 7 seconds. So 8 and 7, 15. So up to 15 seconds, it keeps that same velocity. All right, so 15 midway between 14 and 16. So here, all right, so up to this point, it maintains that 10 meters per second. All right. And then the last stage, it slows uniformly until it comes to rest after 4 seconds. So 15 and 4, 19. All right, so it comes to rest in 19 seconds. So that's at this point here. All right, so just going to place a little marker here. We're just going to join, just going to zoom back out, right. Okay, so that's our sketch for 3 marks. All right, so let's go on to part 2. Calculate the distance traveled by the object in the second part of the journey. So in the second part of the journey, which is this part here, I'm just going to use a different color. All right, and make the shape for that second part of the journey. And you will see that it's a trapezium. So the parallel sides, let's get the length of the parallel sides. So the first parallel side will be 4. That's the first red line there. The second red line is the next parallel side, which the length is 10. And the width of the trapezium, or the height, if you know the trapezium were rotated, will be 3. Because remember, this was at 5 seconds here, and this is at 8 seconds. So that's a difference of 3 seconds. So distance traveled by an object for a velocity time graph is the area under the curve for that particular part of the journey. So we're looking at the area of this trapezium, right? Which will be half the sum of the parallel sides times the height, or the width in this case. Right? So it's a half of A plus B, which will be the sum of the parallel sides times the height. Alright, so A and B would be 4 and 10. So 4 plus 10 times the height, or the width, which is 3. Right, so we have a half of 4 and 10 is 14. Half of 14 is 7, and then 7 times 3 is 21 meters. Okay, so that's the distance traveled by the object in the second part of the journey, right? And that's 3 marks. So let's finish up part 3. For 2 marks, determine the object's acceleration in the final part of the journey. So the final part of the journey is when the object is slowing down in 4 seconds, right? So it was traveling at 10 meters per second and it goes completely down to rest at 0, right, in 4 seconds. So therefore, we know acceleration is change in velocity over change in time. So change in velocity, right, if it was 0 meters per second at the end, from 10 meters per second it was traveling at. And remember the time, it was 19 seconds that it came to rest at, and the velocity when it was 10 was at 15 seconds, right? So that gives you the 4 seconds there. And 0 take away 10 is negative 10. Now remember why the answer is negative, right? Negative 10 divided by 4 will be minus 2.5. Right, because the acceleration is negative because, of course, the object is slowing down, right? Because, of course, deceleration is negative acceleration.